6.07 quiz, which is due today. And link to Nearpod is in the chat. If you by chance did not do so well on the quiz, but you did Nearpod along with me, I will consider that for credits. 6.07 quiz, compound probability, question 1, variety 1. So a bag contains 5 yellow marbles, 7 pink marbles, 3 purple marbles. Gordon selects a marble without looking. Remember, it is important to always find the total number of marbles first for probability or mostly any math question. I will find total number of marbles. So total marbles is 5 plus 7 plus 3. Total number of marbles in this particular bag turns out to be 15 marbles. Any questions? It's important that you need to know your total. Then the question says, what is the probability that he selects a yellow marble? He selects a yellow marble or purple marker, or marble, or purple marble. Oh, tongue twister for me. Purple marble, right? These are the two favorable ones. We want either yellow or purple. The word or in probability. See here, the word or in probability means add, right? So our favorable outcomes, if you're thinking about favorable outcomes, right, will be, I'm going to say, okay, probability of yellow or purple is going to be, we will add, right? We'll do 5 plus 3 over 7. No, over 15 total, right? Over 15. That is how you will find probability of yellow or purple, right? 5 plus 3. And you get an answer that is going to be 8 over 15. That is going to be the chance of picking either a yellow or a purple marble. The word or in probability represents addition. Nina, you are absolutely right. Right? Are there any questions? Does it make sense? And the correct answer is going to be answer choice D, 8/15. Let's look at question 1, variety 2. Will be very similar. Let's see. It says a box contains 4 oranges, 9 apples, and 3 pears. Let's find total fruits. Total fruits, we add 4 plus 9 plus 3. You get a total of how much? Get a total of 16. Everybody agrees? Total number of fruits we are talking about is 16 fruits. We want the probability of selecting an orange or a pear, right? Orange, there are 4 oranges, there are 3 pears. So how do we express it? We will say, then probability of oranges or pears will be, because that there are 4 oranges and 3 pears, we gotta combine, we gotta add. The word or is talking about adding over the total, that is 16 fruits. So 4 plus 3 over 16. Nina says 7/16. I agree. Answer 7/16 looks correct. 7 over 16. Answer choice C is correct. Remember, the word or in probability represents addition. We will be adding the two numbers. So C looks correct. Nina, you picked a different answer in Nearpod. 7/16. Joycelyn, welcome. And here is the next third variety of question 1. Third variety of question 1. A bucket holds 10 white golf balls, 3 pink golf balls, and 5 yellow golf balls. So let's find total number of golf balls. 10 plus 3 plus 5, altogether 18. Right, there are a total of 18. We want probability of white or pink. Remember, the word or means add. White is 10, pink is 3. These are favorable outcomes that we are looking at. Altogether 10 plus 3, we get 13. So we can say probability of white or pink is going to be 13 over 18. over 18. Answer choice C looks correct. Are these questions hard or do they make sense? Everybody understanding? Andre, Nina is definitely responding back. Andromeda, Taraji, Glandy, Noah, EJ, Ayana, Joycelyn, Joycelyn doing well, Edgar, Eric. Feel free to give us feedback as we go over the questions to make sure you understand them. Ayana, I get to see you. Nice. This is question 2. First variety. Alice spins the spinner 2 times. If you attended my session yesterday and today, you probably saw we were talking about tree diagrams. So a spinner is spun twice, 2 times. What is the probability that the spinner will stop on an A and then B, or on a B and then A? Right? It is important to think about this. So first spin, right? Let's talk about first spin. First spin, the spinner might get A, B, or C, right? You might get either A, B, or C, right? Everybody agrees? This is first spin. Let's talk about second spin. Second spin. So in the second spin, if the first spin is A, the second spin might again land on another A. Right? So now, first spin A, second spin also A. This is my first possibility. Or maybe the second spin is not an A, but second spin might be a B. So therefore I can say, okay, first spin might be A, but second spin might be a B. Or maybe the second spin was not a B, but it was a C. That creates this third possibility. Then I would say, okay, first spin will be an A, second spin could be a C. This created your 3 possibilities for spinning the spinner twice. Remember, there will be branches coming out of B and C similar to those. So possibilities will be either first spin lands on B, second spin lands on A, right? First spin on B, second one on A. These are 2 spins. Or maybe not, second spin doesn't land on A, but it lands on B again. So B and B. It's important to understand how the tree diagram works. Or maybe it didn't land on a B in the second spin, but it actually landed on C. So B, C are going to be the outcomes, right? And so on. We will be creating those three outcomes from letter C. 1, 2, 3. It would be a little bit hard, so it could either land on A, B, or C. And we will go ahead complete the outcomes also, okay? So first spin might be on C, second might be on A, first spin might be on C, second spin might be on B. Or both the spins might be letter C. Now these are all the outcomes. This is how you list them out with curly brackets. At the start and at the end. This is a professional mathematical way of listing out all possible outcomes that we call sample space. Okay. Now let's focus on the question. Question says, we need what is the probability that the spinner stops on A and then on B? This is that chance, right? A and then B is this green chance. Or B and then A. B and then A will be this, right? And what do we gotta do to the two? We gotta be adding. Or means adding. So there are altogether two favorable outcomes, A and then a B, B and then an A. There are two outcomes out of a total of 9 possible outcomes. Does that make sense? That are going to be favorable, right? A and then B is over here. B and then A is right there. There are actually two possibilities out of the 9 to get that. Does it make sense? Answer choice C, Nina? How? 2 out of 9 cannot be simplified to 1/3. 2 out of 9 will be 2 out of 9. Anybody has any questions? Let us know. This is how it looks like in the tree diagram. The second and the third variety are about the same spinner, so you will get more and more practice. So Maria will spin the arrow on the spinner 2 times, and this is the spinner has ABC. Let's write down all possible outcomes, everybody. No, we will write down over here, so they will all fit well. Okay. Outcomes. Now without the tree diagram, because you guys are well versed. So first outcome, right? First spinner lands on A. The second spin might also land on A, right? One option. First spinner might land on A, but second spinner might land on B. Another option. First spinner might land on A, but second spinner might land on C. These are the three options, right? For first spinner on A. Then we can say, okay, maybe spinner, the first spin, it didn't land on A, it landed on B. Second spin can be an A. One outcome. First spin could be a B. Second spin can also be a B. Another possibility. First spin will be a B. Second spin might be a C. Now we got 6 outcomes. Remember, the third branch of the tree is still missing. We got to put those there. So we can say, okay, maybe in the first spin we got C. Second spin we might end up getting A. Or first spin we get C. Second spin we might get B. Or we complete that. First spin is a C. Second spin is also that rare option of C again. And we do close the curly brackets. This is mathematical way of writing the outcomes. Nina, yeah, they gotta be 9 outcomes. You are right. Now let's see what we are looking for. We want probability that the arrow will stop on the same letter twice. It will stop on the same arrow twice. Okay, it stopped on same arrow twice. Stopped on same number, same letter twice, stopped on same letter twice. It happened 3 times that it stopped on the same letter out of the 9 total times. Does it make sense? Repeated letters that happened 3 out of the 9 times. That we can say 1/3 in simplified form. And answer choice C looks correct. Are there any questions? Glendy, you have a question? Let me know. The screen looks laggy. Isaiah, refresh and then join again. Hopefully it will work. Refresh your page and then join again. Well, I'm going to see if it lets me copy. So we can copy this onto, it will just copy on the same slide, sadly. We will go ahead and sketch out this outcomes again in the third variety of question 2, and that's just going to be good practice. So again, Berno will spin the arrow on the spinner 2 times. So let's go write down all outcomes. Everybody practice along with me. It's going to be just good practice. All possible outcomes. So first spin A, second spin again A. First spin A, second spin could be B. First spin A, second spin could be C. Or first spin was not A but B. But second spin A, first spin B, second spin also B. First spin B, second spin C. These are 6. These are the top 2 branches only that contain 6 outcomes. Then first spin might be a C, second spin might be A. First spin might be C, second might be B. First spin might be C, second spin might also be C, one of the rare possibilities. We got all our outcomes, right? The question says, what is the probability that the arrow will stop on C at least once? No C's here, no C's, at least once, yes. No C's, no C's, at least once. We see here. There's at least 1 C here, at least 1 C here, and 2 C's here. So out of the total 9 possibilities, we see at least C 1 time in this 1, 2, 3, 4, 5. 5 out of the 9 times we see at least 1 C. Do you guys all agree? Marcus, welcome. 5 9s. Nina also got 5 9s. Jocelyn did 5 9s. Marcus got 5 9s. Let's move on to question 3. Question 3, I pre-filled out some information to save time. I gave you outcomes already, so we can save some time. A school band sold 30 raffle tickets. Each ticket is labeled with a number from 1 to 30. One winning ticket will be drawn. You guys see, I listed out from 1 to 30. Pre-filled out so we can save time. These are the raffle numbers, right? From 1 till 30. We want what is the probability that the number of the winning ticket will be a multiple of 4. Let's see if multiples of 4. This is multiple of 4, multiple of 4. Everybody mark your multiples of 4s. You want either multiples of 4s or means add, or number 19. And this is number 19. So all these shaded ones are favorable outcomes, right? Total outcomes are 30 because there are 30 tickets. Multiples of 4 or the number 19 altogether are 1, 2, 3, 4, 5, 6, 7, 8. I got total 8 favorable outcomes. Did you guys too get 8 favorable? Oh, Joycelyn did. Sean, 8 favorable outcomes did you get out of 30? Multiples of 4 are 7, yeah. And there's 119. Nina also got 8 out of 30. And we will simplify by 2. Half of 8, 4, half of 30, 15. This is going to be the final answer. We always provide simplified answers. Otherwise, the quiz might not consider it correct. So the answer is going to be 4 out of 15. Let's go ahead, look at another similar question. That will be question 3, variety 2. So an adventure game has a number cube with 12 equal size faces. I went in and listed the outcomes from 1 to 12. Right? It has 12 faces numbered 1 through 12. So these are the possible outcomes. What is the probability of rolling a 4? Here is the probability of rolling a 4. Or multiple of 5. Multiples of 5s are here, 5 and 10. There are only 2 multiples of 5. So altogether, out of the 12 total outcomes, our favorable outcomes are 1, 2, and 3. There are 3 favorable outcomes. Remember to reduce your fraction in lowest terms. We'll simplify by 3. It's going to be 1/4. So the chance of rolling a 4 or a multiple of 5 is actually 1/4. Are there any questions? Joycelyn heading in the right direction. What about others? Does anybody have any questions? Let us know. We'll move on to third variety of question 3. And here is third variety of question 3. A board game has 25 cards. Each card is printed with a number from 1 through 25. I listed out the numbers for us. Samir shuffled the cards and then selected one card. What is the probability that Samir selected a card with a number less than 4? Well, a number less than 4 is 1, 2, and 3. Right? Numbers less than 4. Or multiple of 9. So multiples of 9 are going to be 9, 18, 27 is not there. So these are all the favorable outcomes out of 25 outcomes. So total outcomes are 25. That goes in the denominator. Favorable outcomes are 1, 2, 3, 4, and 5. There are 5 favorable outcomes. Numbers less than 4 or multiple of 9. There are 5 such numbers. So 5 over 25. Reduce it by 5. Becomes 1 over 5. Good, Joycelyn. Marcos, I see an actively working slide. Sean. Nina, I want to see some answers from you. Edgar, Noah, actively participate. So if you guys don't do well on the quiz, I can still give you credits. We will look at question 4, and question 4 will involve again some decimal answers like we saw some yesterday. A computer is used to pick 2 letters, one after the other from ABC. Each letter can be picked more than once and has the same chance of being picked. The possible outcomes for the experiment are shown in the table. How many outcomes are given in the table? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 outcomes. Total outcomes are 9. Everybody agrees? There are 9 total ones. I counted A, B, AC, BA, BB, BC, CA, CB, CC. There are 9 in all. What do we want? We want AA. AA is just 1. Or we want BB. And BB is also 1. Altogether, favorable outcomes are actually just 2 out of 9. This question did allow you to use a calculator. So if you did 2 divided by 9, it should give you the decimal value. 2 divided by 9. It should give you the decimal value. This is what I got when I did the calculator thing. It gave me calculator icon on this one. 2 9s, you just divide 2 by 9, you get 0.222 repeating. Right? Any questions? Next one is another very similar one. And here it says a computer is used to pick 4 letters, one after the other from PQ. Each letter can be picked more than once and has the same chance of being picked. The possible outcomes for the experiment are shown. Computer can pick all P's, Q triple P's, Q, P, P, Q, and all these are different outcomes, right? Let's count. 4 outcomes here, then 4 more 8, 4 more 12, 4 more 16. There are total 16 outcomes. There are a total of 16 outcomes. Xavier, feel free to type your question, or you can also wait until the end of the session and I'll be able to help you. Right, Xavier? Feel free to type it out so I know what is your question and I can help you. There are 16 total outcomes. We want all P's. All P's is just one time. Or all Q's. All Q's is also just one time. Oh, Xavier, I have not heard about that yet. Xavier, I know that teachers will get some duty on the K-12 zone, so we can monitor you. Those duties have not been assigned to us yet. So I am actually not aware. But this is a work in progress. I think it's going to be more active K-12 zone in the next semester, and you'll be able to talk about it better. Nina did the decimal of 2/16 and says 0.125. 0.1250. Jocelyn also got that. Right? 2 divided by 16, you will get 0.125. Let's look at the next variety of question 4. And all of these question 4s look very similar. So here, a computer is used to pick 3 letters, one after the other from A, B. Each letter can be picked more than once and has the same chance of being selected. The possible outcomes for the experiment are given. The total outcomes given in the table are 2, 4, 6, 8. There are 8 total outcomes. And let's think about favorable outcomes. Favorable outcomes are A and then B. A and then B, right? Then A, B, A. I see this one. No problem. 1/8, yeah. Nina, you're right. That's just that one. And you want to change it to a decimal? Joycelyn was very fast, say 0.125. It is the same question as the previous one. 2/16 was 1/8, and that's 0.125. Students, from a little bit extra on this question, for STAR test purposes, if you happen to remember that 1/8 is 0.125, it will make your life a lot easier. Okay? If you know 1/8 is 0.125, it will make your life a lot easier. This is like a benchmark fraction. I'm going to recommend you to remember. Then what happens if there is a question about 3/8 and you do not like 3/8? 3/8 is not a good fraction for you. What you can do in your mind, you know that 1/8 is 0.125. 1/8 is 0.125. You will multiply it by 3, and that will give you, okay, then you can handle your decimals from there. Rather than using 3/8 and you don't like it, you can use your decimal value of 3/8. And that is something going to be 0.375. I know a lot of my benchmark fractions that makes my life easier, and it makes it easier for me to cross-check my answers. Some people don't like 5/8. Now, you can also do 5/8 because 1/8, then you can multiply it by 5 and handle the decimal. See? So if you know some benchmark fractions, it's going to be helpful for STAR test. I say 1/8 is important. Okay, question 5. What was the answer for the last one? Glendy, we will look at it at the end. Oh, Glendy, if that was question 4, last two answers were 0.125. Variety 2 and variety 3, 0.125. This is question 5, variety 1. A 6-sided number cube is tossed and a coin is flipped. And here is the sample space, right? So your cube might land on 1, and coin lands on 8. Your cube lands on maybe 2 and coin lands on 8. Cube lands on 3, coin 8, 4, 8. All these are possible outcomes of rolling a coin and a cube. Tossing a coin and rolling a cube, right? What is the probability of rolling an even number? Rolling an even number and flipping tails. So you need tails, right? That means this side, an even number. Even number and tails, even number and tails, even number and tails. Does that make sense? 2 is even, tails, 4 is even, tails, 6 is even, and then tails. So there are 3 such outcomes out of a total of 12 outcomes. Are there any questions? There are 12 outcomes, and 3 are the favorable outcomes that you want: even number and flipping tails. We will see further the word and in probability has to do with multiplying. But in this question, you could just see and answer it without multiplying or doing anything, right? 3/12, yeah. And simplify it by 3. It is going to be 1/4. Are there any questions? When I say it is and represents a multiplication question, I mean, what is the chance of getting an even number on a number cube? What is the chance of even numbers on a number cube? There are 3 even numbers out of 6 numbers, right? What is the chance of tails on flipping a coin? Half. So if you multiply, you end up getting same answer. 3 times 1 is 3. 6 times 2 is 12. Right? That is why I was saying the word and represents multiplication. Because if you did with possible outcomes, or you did using multiplication rule, you should still get the same answer. Let's go ahead, look at question 5, variety 2. Nina, I see your hand is raised. How do I help you?
I was wondering if we can go back after question 5, if we could go back to question 3.
Absolutely, we can go back to question 3.
Okay.
Right? If anybody has any other questions, feel free to let me know. We won't end the session abruptly. We'll make sure everybody gets answered. This is question 5, variety 2 again. They're rolling a 6-sided number cube and tossing, and a coin is flipped. Here is the sample space. Right? Sample space is given to you. Cube might land on 1, coin on heads, cube might land on 2, and then heads, and so on and so forth. We want probability of multiple of 3 and flipping heads. So I'm going to confine myself to heads and multiples of 3s. This is multiple of 3. 6 is a multiple of 3, and we got heads. So there are basically only 2 favorable outcomes. Multiple of 3 and heads is 2 favorable outcomes out of 12. And you can simplify that by 2, which is going to be 1 over 6. If you are thinking about the word and is multiplying and thinking about it in that way, I will also teach you. Yes, 1, 6, Nina. Multiple of 3 on a number cube, 1 through 6, multiples of 3 are 2 numbers. Number 3 and number 6 are multiples of 3. They're 2 numbers out of 6 on a cube that are multiples of 3. Chance of flipping heads is just half. Heads, tails, chance of flipping heads is half. So if you multiplied 2, 6, and 1/2, you still get 2 over 12 without using all possible outcomes. You should know both the ways. On my test and STAR test, they might not give you these outcomes. They might not give you these outcomes and make it easy. They'll just give you this part of the problem. So you should know, when you roll a number cube, multiples of 3 are 2 out of 6. If you flip a coin, heads is 1/2. The word and strictly in math is multiplying, multiply them. We'll look at the third variety for question 5. Again, a 6-sided number cube is tossed and a coin is flipped. We want probability of a number greater than 2 and flipping heads. Number greater than 2 and heads. Greater than 2 and heads. Greater than 2 and heads. And here they are. There are 4 such possibilities. 4 such favorable outcomes where we have number greater than 2 and heads. So 4 12ths. And simplify it by 4, get 1/3. I will also show you the mathematical way of doing if sample space was not given to you, right? How many numbers on a cube are greater than 2? There are 4 numbers on a number cube greater than 2 out of the 6 numbers. The word and is multiplying, and what is the chance of getting heads on a number on flipping a coin is half. Tails and heads, so chance of heads is 1/2. Chance of number greater than 2 is 4 6. Multiply them and you should still get 4 12ths. And this marks all the 5 questions that were on the quiz. We will go back to your request. I know Glendy had a question, Nina had a question, and we will look at those. This is question 5, this is 4, this is question 3, Nina. It's about to load. Nina, is this your question 3? A board game has 25 cards?
Yes. Not this one, it was the one with 30.
30 was the first one. Here you are. So we wanted multiple of 4, right? 4, 8, 12, 16, 20, 24, 28. There were 7 multiples of 4. And 19, there's this 119. Altogether, we had 8 favorable outcomes, Nina, out of 30. We had 8 favorable outcomes out of 30.
Okay, thank you, because
Yep.
I was confused. Like,
Uh-huh.
wait, we went over this? I was like a little confused. It was
Uh-huh.
just a little confusing. Thank you.
No problem. Anybody else wants me to go over a certain question? Feel free to let me know. Andromeda, Marquez, Alex, Tiam, Nina, your hand is still raised. Eric, no questions? That marks the end of the session. Thank you so much for joining.